The 45 in the corner would be referred to as the complement of this scenario, which would be something that's not a Republican and not an independent, which would mean that it's a Democrat, which again, there's 45 Democrats. So that's why the 45 is outside the two circles, but it's in the big rectangular box. So if we look at part A here, it says that find the probability that the senator is Republican. Okay. So there's 53 Republicans out of, it looks like, is that 100? Yep, senators. And so that's just your division there, 53 out of 100. Find the probability of them being independent. There's only 2 independents. So again, it would be 2 out of 100. Both those numbers can get divided by 2. So that would be 1 out of 50. But usually, like in this scenario, I'd probably rather have it as 2 out of 100 because you want to know, in my opinion, how many is the total. But because sometimes when you reduce it down all the way, it's not actually more helpful than leaving it big. It just kind of depends on the scenario. So if we're looking at find the probability that a senator is either Republican or Democrat, or independent, that would be 53 and the 2 together out of the total 100, which would be 55 out of 100. So kind of that's just kind of how you would do Venn diagrams. And you'll see some more in a second where they actually overlap. So reducing that down, I think those both can get divided by 5, which is, I believe, 11. And then 20, 11 is prime. So we are done. If something is mutually exclusive, so mutually when it's the probability that A or B will occur, essentially you just add each probability together, which you'll see in a second here. So we'll come back to that in just a second here. So we've got a new question. It's still the 2019 information, but now it's women and Democrats. And so essentially they broke it down. They're saying that there's of the women in the Senate, there are 8 of them are not Democrats. So I think, if I'm reading this correctly, this would mean that there are 8 Republican women, and there are 17 women that are Democrats in the Senate. And then the 28 would represent men that are Democrats. Okay. So just kind of like getting our mind around, okay, what do each of these numbers mean? And so if you're looking at for part A, what's the probability that a senator is a woman? So there's 8 women Republicans and 17 Democrats out of the 100. Okay, so you just kind of got to read it slowly. Again, making the notes of like what each number means. That 47, I didn't mention that yet. That represents people that are not Democratic and not women. So that means that there is 47 men that are Republican or independent in this situation. So you would probably just say, they'd have to be men, and then they would have to be Republican or independent. Alrighty, so breaking that down, that gives us 25 out of 100, which reducing that down even farther would give you 1 out of 4. Okay, so then the probability that a senator is a Democrat. So if I look at the Venn diagram, we've got 28 Democratic men. We've got 17 Democratic women. And so I just added them together like that to get 100. If you're using the salmon formula up there, essentially it's just saying that you could have done 28 out of 100 plus 17 out of 100. That becomes the same fraction up there. Now I do have to sneeze, so I'm going to mute myself for a second. It didn't come. It's a bummer. Okay, so I've got 45 out of 100 on there. And reducing those down, it looks like that would be 9 out of 20. 9 and 20 don't have any common factors, so 9 out of 20 is that reduced fraction right there. Part C is looking at the probability of being a woman or a Democrat. So when you've got that or situation there, this is accounting for the 8. This is accounting for the 28, and it's also accounting for the 17 there. So essentially, it's all those numbers together, which would be 8 plus 17 plus 28, all out of 100, which I believe is 53. You could have also done the complement there, and you would have seen that 47 and the 53 make 100 together. So you could have done 1 minus 43 out of 100 if you wanted to use that complement concept from the other page. Last one here. What's the probability of a senator being a woman and a Democrat? So that, again, the and is usually in this scenario, it's referring to the overlap. Okay, so again, when you see the and, you should think of that overlapping space. So the overlapping space, it looks like there's 17 in the overlap out of the 100 total. And since 17 is prime, that cannot get reduced down any farther. So 17 out of 100 would be our final answer. Okay. So the next question here. So the reason why this next formula is helpful is because usually things are not mutually exclusive. Like it means they can't happen at the same time. And so essentially, don't get too tripped up by the formula, but the reason why this general formula is different from the one before is because you like when you have the mutually exclusive, there's no overlap. So one more time, notice for the mutually exclusive, there is no overlap. So when there is overlap, you have like this weird situation where you have to subtract out. It's kind of like if I just did a little circle here, if you do A and then B, and then that in the middle is A and B. If you did just PA plus PB, you're counting this middle twice. So this is basically to subtract the middle because it got counted twice, which doesn't actually matter in terms of like your understanding here, but I'm just trying to like give you an overview of why this formula is different from the one before. This one will be used a lot more common than the other one. So that's why I'm trying to explain it a little bit more. So if we've got these 7 balls in this bag, some are gray and some are white, we're curious if the selected ball has a number from 5 to 6. So there's 2 of those, and there's 7 balls total. So the odds of that happening are 2 out of 7. Okay. We're curious, what's the probability of the selected ball being gray, which would be 3 out of 7. And then the selected ball has a number from 5 to 6 and is gray. From 5 to 6 and is gray, that's only the 5. So that would be a 1 out of 7 scenario. Again, you could have done when we get to the or situation down here, it says the selected ball has a number from 5 to 6 or is gray. So 5 to 6, that would be those two balls there. And then the 4 and the 1, I can include those two because it can be from 5 to 6 or gray. So that would be 4 out of 7. So essentially what this next question asks you to do is plug in these numbers to see how it works. So the probability of A was 2 out of 7. The probability of B was 3 out of 7. Probability of A and B was 1 out of 7. And so when I reduce that down, I get 5 out of 7 minus 1 out of 7, which is equal to 4 out of 7. So essentially what this is trying to show you is that the formula does work. And it tried to break it down in like a simple, like just 7 balls, some are gray, some are white. Because there was like that overlapping scenario there where like if you had A and B again, the probability of A happening was 2 out of 7. The probability of it just being gray was 3 balls. And then the overlap in the middle was that there was just 1 ball there. And this is when they were like 5 to 6 or gray. So that's kind of what the Venn diagram would look like out there. And then if there was like a little box outside the box would have been, there was only 1 that wasn't accounted for, which would be, I'm not sure if I'm saying that right. I might be doing too much talking. It's 3 gray balls. Huh. Oh, it's because this A would have to only have 1 in it. Yeah. And then this B would have to have 2 in it. Okay, that's why I jacked it up. That's my bad. This would be a 3. I'm gonna stop talking. That's the right answer, and that's because the A. Sorry for that that little blunder there. It's because I did it off the top of my head and was going rogue. The 1 and the 1 make the 2. The 2 and the 1 make the 3, and then everything else is where that 3 on the outside comes. I'm gonna stop talking because I'm gonna get you guys more confused if I go rogue there. That's why we prepare our notes and don't just do random stuff. Okay, so this is where we want to kind of trust the formula because we don't have a Venn diagram given to us. And so if we look at this, the House has 102 women, and 13 of them are Republican. And then there's a total of 435, and 199 of those are Republican. And they're only choosing one of those for the interview. And so what's the probability that the representative is either a woman or a Republican? So we would want to do the probability that someone is a woman or Republican. And I'm going to trust that formula over there. So that would be the probability that somebody is a woman, adding the fact that they're a Republican, and then subtracting out the probability that they're a woman and Republican. Okay. Because again, that overlap, the minus part would have gotten counted twice during the process there. So it looks like there were 102 women out of the 435. It looks like there was 199 Republicans out of the 435. And then the women that were Republican, there was 13 of them out of the 435, which when you add and subtract that all, that ends up with 96 out of 435, which that decimal would be 0.66. Okay, so again, that formula is a little wild. I do not believe it's on your test, so that's probably something worth really knowing. It wouldn't be more than like 2 questions on test 4, because if test 4 is like your final, there's just only so much that can be on there. So this wouldn't be a whole lot, but that formula is worth knowing. So what's the probability that they're a woman and a Republican? We actually already figured that out right there. And that would just be 13 out of the 435, which would be a 3% chance. So the Republicans are not having a ton of women out there these days, or when this book was written. Okay, so looking at number 5. We've got our deck of cards, and we're curious. What's the probability of it drawing a face card or a heart? Oh, painfully bad. It's not connecting. It wouldn't be that great anyway, even if it did connect. There we go. Okay, so probability of a face card happening. So this is kind of hard without making the list here, but there's 4 jacks, 4 queens, and 4 kings. So the probability of a face would be 12 out of the 52 cards. The probability of a heart. So if you're kind of thinking back to that table from the previous question, there was 13 hearts. And so again, if you want to kind of look at that overlap there, which maybe I will look at. So like for this question here, the probability of a face card should be these 12 over here. And the probability of a heart would be all these hearts. There's 3 in the overlap, and we counted the 3 twice if I count the 13 blues and the 12 greens. And so that's why here you have to subtract off the probability of face and heart, because it was counted twice. So you want to subtract off those 3, the jack, queen, and king of hearts. Okay. So I believe that gets you, is that 22? Yeah, 22 out of 52, which would be 11 out of 26, which has a fraction. We could leave it like that. Or if you wanted to make it a decimal, it would be 0.42. Again, when you're asked that or scenario, you really got to trust this formula here that's coming up. And then it's interesting that they keep asking this out of order here, but essentially we've already figured out what's the probability that's a face card and a heart. That's right here. So that would be 3 out of 52. Okay. Just a couple more questions, and then you guys will be free to go here. Which this next part can get a little bit complicated, so make sure you're kind of locked in here. I had a lot of homework questions about this stuff last semester. I want to do this. Sorry. Oh, they don't give me the protractor. What a bummer. Okay, so It says in the hospital, there's 86 nurses and 41 doctors. So I'm going to add that into the chart right now. So there's 86 nurses and 41 doctors in the total. It says that there's 70 nurses are female and 14 doctors are female. And so now we want to kind of figure out this information from here. So hopefully you can see where I'm getting 16 from here, because if there's 86 total nurses and 70 of them are female, that means that the other 16 have to be male. And then where I'm getting this 27, I've got to have those add up to 41. So just 41 minus 14 gives you 27. And then for the total at the bottom, you can just go ahead and add. So that gives you 4384 and a total of 127 total doctors and nurses. So we're going to trust our formula. It says find the probability that they're a nurse or a male. So that or probability is its probability of a nurse plus the probability of a male minus the probability of a nurse and a male. So I know that's a lot of writing. But now we just kind of go to the chart. The probability that they are a nurse is 86 out of the 127. The probability that they're a male, it looks like there are 43 males out of the 127. The probability that they're a nurse and a male is it looks like it's 16 out of the 127. So again, this formula, like I don't know how to do this question another way. You end up with 113 out of 127. So a nurse or a male, I guess you could have done, a nurse. So if you wanted to do the probability that they were a nurse or a male, you could have done 86 and 27 together. So yeah, there's multiple ways you could do this. I guess you don't have to use this formula. You can think about it logically if that's kind of how your brain works more. If you divide those two numbers, you get 0.89. So for part B, it says, find the probability that it's a nurse or a female. So maybe I'll do this more logically. So if we've got a nurse, there's 86 total nurses. And then we've got 14 female doctors. So it looks like I should add those together. Out of the 127 people, there's no overlap because the 86 is only nurses, male and female, and then the 14 is just female doctors, so there's no overlap. And that would give you 100 out of the 127. So you've probably been like, dude, I don't want to use your formula. And then I just showed you that you actually don't have to use it. So kind of whatever do you, I guess. I guess I just proved myself wrong. See if the chat's like told you so an hour ago. Okay, almost done here. So find the probability that the subject is a doctor and a male. So it looks like if they're a doctor and a male, there's only 27 of those. So I believe you can just go straight to it. 27 out of the 127. Yep, which would be 0.21. So yeah, maybe you should not listen to me and not use the formula if you don't want to, but it's up to you. Okay, last one here. So the packet of stickers, awesome. Juniper loves stickers. There's 9 small, 7 big stars, 8 small rockets, and 5 big rockets. He's going to pick one of the stickers to put on the artwork. What's the probability of the sticker chooses is small or a star? So for me, if it's small, so you can think about it logically as if it's small or a star, there's 9 small stars, there's 7 big stars, and then there's 8 small rockets. So the only thing not included is the 5 big rockets. So I believe we can just do this by 9 plus 7 plus 8, all divided by the total of 29. Which it looks like that would be 9 plus 8 plus 7 is 24 out of the 29. So, yep, you could do it like that. If you divide those two, I think you get 0.83. You definitely could use the formula if you want. If you have the notes pulled up, I kind of walk you through like how you would use the formula there. But the more I teach this, it's like, wow, maybe I shouldn't use the formula because it makes it more confusing. It broke it down into, there was 17 small stars, 17 smalls, 16 stars, and then, yeah, that's way harder. Don't do that. That's a waste of your time, in my opinion. I would definitely just do that. So sorry to the people last year. Hopefully they forgive me. Definitely not watching this.